10 hours straight. He's a machine.
Oh, I know how to code.
Show me.
Well, we've made a lot of headway so far looking at this introduction into R coding. We've looked at software installation and basic setup. We've looked at the most common use cases for the majority of symbols on your keyboard. We've looked at functions, packages, and objects. This time, we're looking at different types of data formats. That's right, we're looking at vectors, matrices, and arrays. Welcome to the Skullywag Lab. I'm Dr. Rex. In this set of tutorials, I'm presenting a bare-bones introduction to the basic fundamentals of R coding. In many scripts of the code that you come across, as well as within the environment of stored information that you have on the right side window, you'll often come across numbers that are contained within square brackets. These numbers are most often referencing the dimensions of selected data. In this tutorial, we're going to take a closer look at how this works. So let's get stuck in. For the purposes of R coding, a vector represents a list of data points. When you see vectors mentioned in directions for using certain functions, it's usually referring to one-dimensional data in this format. Now, a matrix has the same one-dimensional data as a vector, but a matrix extends into the second dimension. This forms a table-style format with rows and columns that many datasets generated in Excel will tend to look like. Finally, an array is typically used to describe data in a three-dimensional format, which involves matrices stacked on top of each other like layers. Now, I say typically because all three of these formats of data are technically arrays. But if this term was used to describe one-dimensional data, it would usually be called a one-dimensional array. Or if it was used to describe a matrix or two-dimensional data, it would be called a 2D array. So usually when you hear array, it's referring to three-dimensional data. Let's begin by generating a vector consisting of numbers 1 through 18. Let's call this vector Vesper, after that awesome martini invented for James Bond. Vesper is now stored in the environment, and we can check it over in the console by typing its name and hitting Control-Enter. Now, all those numbers are really fun to type and all, but an easier way to generate this vector is to use the colon, called the sequence generator. In this case, we just type 1:18, and this represents every number between 1 and 18 inclusive. You might notice that making a vector this way lists the vector as integer rather than numeric. This is just a formatting thing to do with whole numbers versus decimals, and you don't really need to worry about this very often, because as you can see, the same data is still printed in the console. Now let's say we wanted to make a vector of numbers 1 through 18, but this time without numbers 7, 8, and 9. Well, you can either type out all the numbers you want to include, or if any of the numbers are in sequence, you can use the sequence generator again. And this makes a vector with the numbers you are after. Okay, now let's generate a matrix using the same numbers. We do this using the matrix function. Let's take a look at that. If we look into how this function works, we need a vector of data and either a number of rows or a number of columns to extend it into a second dimension. Let's allocate this matrix to an object called Manhattan. You know, I had a Manhattan in Manhattan once. It was a glorious experience. The matrix has now been saved into the environment with dimensions of 1 to 3 rows and 1 to 6 columns. But we can also create the same matrix using our saved vector Vesper. So let's do that. And if we now type the name of the matrix, it's been printed in the console in this format with 3 rows and 6 columns. Notice how the numbers of the vector have been distributed in columns, so that the first column is 1 to 3, next is 4 to 6, blah blah blah. Well, we also have the option to distribute the numbers via rows instead by using the by row argument in the matrix function. This is a logical argument, meaning it can only be true or false. So after making that change, you can see that the matrix now has numbers distributed across rows instead. Now let's make an array of the same numbers. Woohoo! If we look at the array function, you can again see we need a vector of the data and also the dimensions of the array. Let's allocate this array to an object called aviation. Now this is a very special kind of gin sour, also originating in NYC. Again, we have the numbers 1 to 18 distributed across dimensions of 2 rows, 3 columns, and 3 layers. Now remember this ordering because it never changes. All dimensional descriptions in R follow the order of rows, columns, then layers. Typing the name of the array will print it in the console. And because the console is 2D and the array is 3D, the format is to print each layer at a time. The first layer being 1 to 6, the second 7 to 12, third 13 to 18. Sometimes, maybe we don't want to process or analyze all of our data points. Sometimes, maybe we just want a few specific values, or maybe we want to leave a group out of our analysis. For our final exercise, let's extract a few specific data points of interest. Now you remember how the ordering of rows, columns, and layers never changes? Well, this can be used as a coordinate system to isolate specific regions of data. And we do this using the square brackets. So let's type the name of the data set followed by square brackets, and within those, 1, 1, 1. This is telling R to print out the data point positioned first in the rows, first in the columns, and first in the layers. So it prints the value of 1. If we leave the position of the rows and the layers empty within those square brackets by just typing comma, 1, comma, this is telling R to print out all rows of the first column of all layers. The first column of the first layer in the aviation array is 1 and 2, the first column of the second layer is 7 and 8, and the third layer is 13 and 14. So this is what's printed in the console. Likewise, if we were to leave the rows and the columns completely empty, this is telling R to print out all rows and all columns of the first layer of the array. So we get 1 through 6 printed in the console. If you wanted to work with these new selected data points in further analysis, you would simply allocate these selections to new objects in your environment using the assignment operator. And that's it for our tutorial on vectors, matrices, and arrays.
Yes!
If you stick around for the next tutorial, we'll be covering the basics of plotting and analysis. If you found this content useful at all, don't forget to like and subscribe, and I will catch you in the next one.